Hello, this is Yashveen from Exam Help Web. In this video, I'll be solving paper 2 variant 1, October-November 2022, AS level physics. Question 1a, the boxes in figure 1.1 contain terms on the left hand side and examples of these terms on the right hand side. Draw a line between each term on the left and the correct example on the right. Starting with base quantities. So base quantities would include mass, length, time, temperature, and current. Out of all of them, we've got electric current over here. Then base units. So base units would be for the exact same quantities. Those would be kilograms, meters, seconds, Kelvin, and ampere. So here we've got kilogram. Derived quantity would be a quantity which is derived from a base quantity, and that would be force. And a derived unit is again a unit derived from base units, which is coulomb. B. A set of experimental measurements is described as precise and not accurate. State what's meant by 1. Precise. So precise measurements would be the measurements which have a small range. These are measurements of the same quantity when the values are quite closer together in their magnitude. For example, a set of measurements which would be 2.1, 2.3, 2.2, and 2.1. As you can see, the range over here from the largest to the smallest has a difference of 0.3. And if you compared it to another set of values of, let's say, 2.1, 2.7, and 3.2, the range here would be 3.2 minus 2.1, which has a difference of 1.1. So here the range is quite large, whereas in these measurements, the range is smaller. So this set of measurements would be more precise. And part 2 asks you to explain what's meant by accurate. Accurate measurements would be the measurements of a quantity when the result of measurement is as close as possible to the true value. For example, experimental value of acceleration due to free fall as 9.81 meters per second squared is accurate, whereas if you were to get a result as 10.2, that would be less accurate because it's farther away from the true value than 9.81. C. An object of mass m travels with speed v in a circle of radius r. The force acting on the object is given by the formula mv squared by r. The percentage uncertainties of 3 of the quantities are given in table 1.1. The value of v is determined from force, mass, and radius. Calculate the percentage uncertainty in v. To find the percentage uncertainty in v, you would first have to make v the subjective formula. So that would be the speed is equal to force multiplied by radius divided by time, and you take out the square root of this. The uncertainty of speed over here is the combined uncertainties of all of the other quantities over here. You would sum up the percentage uncertainties of all of these, and that's because all of these quantities are related to each other by multiplication or division. So you would add up their uncertainties. And other than that, as you can see, all of these quantities are raised to the power of 1 by 2 or half, which means you would have to multiply their uncertainties by 2. So we'd start by, for example, doing 3 divided by 2 plus 4 divided by 2 plus 5 divided by 2. This is the percentage uncertainty of force, mass, and radius. Again, we're doing addition because these quantities are related to each other by multiplication and division. And we would divide all of them by half because all of them are raised to the power of half. And this would sum up to 6%. The value of v is 15 meters per second. Calculate the absolute uncertainty in in speed. So now you'll convert this percentage into an actual value. We do that by multiplying 6 divided by 100 with the actual value of speed, and this will give the uncertainty as 0.9 meters per second. Question 2. A steel ball is projected horizontally from the top of a table as shown in figure 2.1. So you've got the initial horizontal velocity as Vx, and remember, in projectile motion, in the horizontal direction, acceleration is 0, which means that the horizontal velocity remains the same throughout the time of flight. However, in the vertical direction, you've got acceleration due to gravity, which is why the vertical velocity would increase in magnitude. The ball is projected horizontally at a speed of 4.9 meters per second. The ball lands on the ground at a horizontal distance of 180 centimeters from the edge of the table. So that would be 1.8 meters from the table. Assume that air resistance is negligible. A1. Calculate the time taken for the ball to reach the ground. So here, as I mentioned earlier, the speed would be constant, and you're given with distance as well, which means you can use the formula speed is equal to distance divided by time to find out the time, which would be distance divided by speed, and that would be 1.8 meters divided by 4.9. This turns out to 0.37. You calculate the vertical component of the velocity of the ball as it hits the ground. Alright, as I mentioned earlier, we would have acceleration in the vertical direction, and the ball starts with a vertical velocity of 0, which means u is 0, acceleration is 9.81 in the vertical direction. The time of flight in the vertical and horizontal directions is the same, so that would be 0.38. You can use the formula v is equal to u plus at. Since this is a constant acceleration situation, you can use the Survette equations, and this would be equal to 0 plus 9.81 multiplied by 0.375, and this comes out to 3.6 meters per second. My bad here, this isn't 0.375, it's 0.37 seconds. 3. Determine the magnitude and the angle to the horizontal of the velocity of the ball as it hits the ground. So velocity over here is the resultant vector of the vertical velocity and also the horizontal velocity, and this would result in the vector which we are concerned with. Vx, the horizontal velocity, which does not change, would remain as 4.9, and Vy, which we just calculated, would be 3.6. And so hypotenuse squared is equal to adjacent squared plus the height squared, which means, using Pythagoras theorem, this velocity would be equal to the square root of 4.9 squared plus 3.6 squared, and this is equal to 6.1 meters per second. And now you want to find the angle that it makes with the horizontal, which means this angle over here, since this is the horizontal side and this is the resultant vector. You've got the opposite side given as well as the adjacent side, so you'd find that you need to use the tan theta over here. So tan theta is equal to opposite over adjacent, which means that the angle is tan inverse of opposite, which is 3.6, divided by the adjacent side, which is 4.9, and this is equal to 36 degrees to the horizontal. B. The ball is projected by means of a compressed spring which is attached to a fixed block as shown in figure 2.2. The ball is placed on a frictionless track in front of the spring. The ball is then pulled back so that the spring has a compression of XO. So this would be the amplitude of the spring. When the spring is released, the ball is projected horizontally as shown in figure 2.3. So when the spring projects the ball, all of the elastic potential energy which is initially stored in the spring would be converted into kinetic energy of the ball. And I say all of it because the track over here is frictionless. That means you don't need any energy to do work against friction. None of the energy would be lost as heat energy. All of the energy which is initially stored in the spring would be converted to the kinetic energy of the ball when it's released. So this seems like we might need to use the formulae of kinetic energy, which is half mv squared, and elastic potential energy of a spring, which is half kxo squared, where this is the amplitude and k is the spring constant. The ball is a uniform speed of steel of diameter 0.016 meters and mass of 0.017 kg. 1. Calculate the density of the ball. So density is equal to mass over volume. Mass is given as 0.017 kg. Now this is a sphere, and volume of a sphere is equal to 4/3 pi into radius cube. Radius would be half of diameter, which would be equal to 0.008 meters, which means the volume is 0.008 meters cube multiplied by 4/3 into pi. And so you'd plug this in here, 0.017 divided by the volume. And this is equal to 7900 kg per meter cube. 2. All of the elastic potential energy in the spring is converted to the kinetic energy of the ball. The speed of the ball as it leaves the spring is 4.9 meters per second. Show that the maximum elastic potential energy of the spring is 0.2 joules. So here again we are given in the question that elastic potential energy lost is equal to the kinetic energy gained. If you were to find the maximum kinetic energy gained, you would also find the maximum elastic potential energy that's lost, and so this would be equal to half mv squared, and that's 1/2 multiplied by the mass of the sphere, the steel ball, which is 0.017 multiplied by the speed squared, and that's equal to 0.2 joules. 3. Figure 2.4. Use figure 2.4 to determine the spring constant of the spring. As you can see in this diagram over here, that extension is directly proportional to force. This means that the spring obeys Hooke's law, and so we can use the formula force is equal to spring constant multiplied by extension to find out the spring constant. You can use any coordinate from this graph, and I will be using 6 newtons and 9.4 centimeters of extension. So we've got 6 newtons divided by the extension in meters, which would be 0.094, and this is equal to 64 newton per meter. 4. Use your answer in B part 3 and the value of energy given in B part 2 to determine the compression of the spring. So we now know that maximum elastic potential energy is half into k into xo squared, and this as calculated earlier over here is 0.2 joules. This is 0.2 joules, and we also know that the spring constant has a value of 64, which means the maximum compression is 0.2 multiplied by 2 divided by 64, and then you take the square root of this, which is equal to 0.079 meters. See, the steel ball is replaced by a polystyrene ball of the same diameter but of a much lower mass. The spring is given a compression Alright, so this is the same compression, XO, and then released. Air resistance on the ball is not negligible after it leaves the spring. Explain 1. Why this ball leaves the spring with a greater speed than that of the steel ball. So again, keep in mind that you would have total conservation of energy. So elastic potential energy of the spring would be converted to kinetic energy of the ball. Elastic potential energy remains the same because you would have the same compression and the same spring, which means the same spring constant. So this would remain the same. Now kinetic energy is mass multiplied by speed squared multiplied by half. As they're telling in the question, this new ball has a lower mass. That means for the total energy to remain the same, this ball has to have a larger velocity, because total energy again here would be equal to the total elastic potential energy, which is the same. To keep the magnitude same, you would have to increase the velocity to counter effect the decrease in mass. 2. Explain why the ball takes a longer time to reach the ground than the steel ball. The polystyrene ball with a smaller mass has a resultant force, which is the force due to gravity, which acts on it. And this force is smaller because it has a smaller mass, so it will take longer to reach the ground. Question 3a, part 1, define power. Power is work done per unit time. 2. Mechanical power P can be calculated using the formula power is equal to force multiplied by velocity. Use the concept of work and definition of power to show how this formula is derived. So power is work done divided by the time taken. Work done is the force multiplied by distance moved in the direction of force divided by time taken. So as you can see over here, we've got force multiplied by distance over time. Distance over time, which is speed, which means that power is equal to force multiplied by the speed. B. The engine of a lorry provides 130 kilowatts of power to the lorry's wheels when it's traveling at a constant speed of 25 meters per second along a straight horizontal road. Show that the resistive forces opposing the forward motion of lorry is 5200 newtons. Alright, let's suppose here's the moving body. You've got the driving force and then the resistive force. If the speed is constant, this means that driving force is equal to the resistive force, hence acceleration is 0 and the speed remains constant. So you can equate both of these, and this means when you use the formula power is equal to force multiplied by speed, you can use this formula to find both driving force as well as the resistive force. So here you are given with the power of the lorry, which is 130 kilowatts divided by the constant speed, and this is equal to 5200 newtons. C. The lorry in B travels up a straight section of road that's inclined at an angle theta to the horizontal as shown in figure 3.1. The lorry has a mass m and acceleration of free fall g. Determine the expression in terms of m, g and theta for the component of the weight of the lorry that acts parallel to the surface of the road. Alright, the component of weight which acts parallel to the road. So here, somewhere around here, the weight would act from the center of mass and it would act downward. That would be mg, the force. Now this is a vector quantity, which would mean it will have two components to it. That would make a right angle triangle. Now here you would have theta, and this side would be mg cosine theta, and this side would be mg sine theta, and the component which acts parallel to the surface of the road is mg sine theta, because as you can see, this is the road and this would be the component. 2. The total resistive force remains unchanged at 5200 newtons. and the engine now provides a greater power to maintain the speed of 25 meters per second. The total mass m of the lorry is 36,000 kg. The angle is 1.4 degrees. Determine the power in kilowatt now provided by the engine. So now not only do you have 5200 newtons opposing the motion of this lorry, now you also have mg sine theta, which acts in the opposite direction to the direction of motion, which means the engine now has to provide greater power in order to overcome this force and maintain the same speed at 25 meters per second. So if you want to find the power, you would use the same formula, force multiplied by the speed. Speed remains constant at 25 meters per second, but remember again, the resistive forces are not only 5200 newtons now, but this would also include the component of weight acting parallel to the ground, which acts in the opposite direction to motion, which means it would act as a resistive force, and the engine would now have to overcome this by increasing the power. So mg sine theta would be 36,000 multiplied by 9.81 multiplied by sine 1.4, and then you would multiply this force with 25, and this would lead to 350 kilowatts of power. Question 4a. Polarization is a phenomenon associated with light waves but not with sound waves. 1. State the meaning of polarization. Polarization is a phenomenon by which oscillations of a transverse wave are restricted to a single plane, and this plane has to be perpendicular to the direction of propagation of wave, since that's how transverse waves would transfer energy. So this phenomenon only applies to transverse waves, in which oscillations are perpendicular to the direction of propagation, and this can be in any plane. So polarization will restrict the oscillations only to a certain plane. 2. State why light waves can be plane polarized but sound waves cannot. And that's because light waves are transverse waves and sound waves are longitudinal waves, which cannot be polarized. B. The two polarizing filters A and B are positioned so that their planes are parallel to each other and perpendicular to their central axis xy, as shown in figure 4.1. The transmission axis of filter A is vertical and transmission axis of filter B is horizontal. Unpolarized light of a single frequency is directed along the line xy from a source positioned at x. The light emerging from filter A is vertically plane polarized and has intensity I0. Filter B is rotated from its starting position about the line xy as shown in figure 4.1. After the rotation, the intensity of light emerging from filter B is a quarter of the intensity which was incident on it. Calculate the angle of rotation of filter B from its starting position. So polarizer B will reduce the intensity of incident light, and using Moles's law, we can use the formula transmitted intensity is equal to the incident intensity multiplied by cosine squared of theta, and this means here we've got the transmitted intensity, which is I0 divided by 4, that's equal to I0 multiplied by cosine squared theta, and so cosine squared theta is 1 by 4 and theta is cosine inverse of root of 1 by 4, which is cosine inverse of 1 by 2, and that's equal to 60 degrees. Okay, so now we found theta. Now theta, which we just found using the formula, is the angle between light and the transmission axis. So for example, here is your polarizer B. This is the plane of polarizer. This is the vertical unpolarized or incident light, and this is the transmission axis, and the angle between this transmission axis and light is 60 degrees between the transmission axis, the new transmission axis of filter B, and the light. This is the angle which you found using the formula. The question is asking you to find the angle of rotation of filter B. Remember, in previously we read that filter B is horizontal, which means the transmission axis looks like this initially. After the rotation, you would see that you would have a new transmission axis. So here you've got the old axis and here you've got the new axis. You've got incident light, which is vertical in direction, and we just found out using the formula that the angle between this light and the new axis after rotation is 60 degrees. Now old axis was horizontal, which means it was at an angle of 90 degrees to the vertical. So if you want to find out this angle, you would subtract 60 degrees from 90 and that would give you 30 degrees. So that is the angle of rotation, after which the angle between light rays and transmission axis would be 60 degrees, as we found using the formula. See, a microwave of intensity I0 and amplitude AO meets another microwave of the same frequency and of intensity quarter of I0, traveling in the opposite direction. Both microwaves are vertically plane polarized and superposed where they meet. 1. Explain without calculation why these two waves cannot form a stationary wave with zero amplitude at its nodes. So stationary wave is formed when waves of the same frequency and wave speed will superimpose. At a node, the amplitude is 0. This is the region where destructive interference occurs and the amplitudes cancel out completely. So the amplitude at a node is equal to 0. This can only happen when the waves that are superposing have equal amplitudes. Intensity is proportional to amplitude squared, which means if the second wave has quarter of the intensity, that would mean it would have half of the amplitude that the first one does. And this means since the amplitudes of the two waves that are superposing are not equal, that means you would not have any node where destructive interference would lead to an amplitude of 0. You would not have any region in the stationary wave where amplitude is 0. So here I've drawn an example. In the first case, when you've got wave A, which let's say has an amplitude AO, and then you've got wave B, which has amplitude of AO divided by 2. This means at destructive interference, when the amplitudes cancel out, when the amplitudes subtract, this would result in an amplitude of AO divided by 2. However, if you had two waves of the same amplitude, they would cancel out each other completely and this would result in an amplitude of 0. And for a node to have amplitude of 0, you need complete destructive interference, and so you would need two waves of the same amplitude. To determine in terms of AO the maximum amplitude of the wave formed. Maximum amplitude will result from constructive interference when the amplitudes of the two waves add up. So for that, to reach the maximum amplitude, you would need to know the amplitudes of the two waves. The first one has AO. The second one has an intensity, a quarter of the intensity of the first wave. And as I mentioned earlier, intensity is proportional to amplitude squared, which means if the amplitude is reduced by half, the intensity of wave would be reduced 4 times, which means the new amplitude is half of the initial amplitude. So now to reach constructive interference, you would add up both of them and this would be equal to 1.5 of the initial amplitude. 5a, state Ohm's law. The According to Ohm's law, at a constant temperature, the current through a conductor is directly proportional to the potential difference across it. B. The variation of current with potential difference for a filament lamp is shown in figure 5.1. The resistance of the filament lamp increases with potential difference. 1. State how figure 5.1 shows this. So resistance is equal to voltage divided by the current, and as voltage increases, this ratio of voltage to current increases in the graph, which is why resistance increases. To explain why the resistance varies in this way. So a filament lamp is not an ohmic conductor, which means its resistance will change. It does not have a constant resistance. In the filament lamp, as the voltage and current increase, the temperature will increase, and this will increase resistance. See, figure 5.2 shows a circuit of a battery of electromotive force 12 volts connected to a linear potentiometer AB and two identical filament lamps P and Q. The battery has negligible internal resistance, and the lamps each have the same IV characteristics shown in figure 5.1. When the slider of the potentiometer is at its midpoint as shown in figure 5.2, the current in battery is 1.78 amperes. Determine the current in lamp P. AB is a potentiometer, which means it has variable resistance. This resistance will change when the slider moves, so the resistance of AB is proportional to the length of the potentiometer. This resistance would be maximum when the slider is at B, and resistance would be minimum when slider is at A. The question mentions that both P and Q have the same IV characteristics, which means that the 12 voltage across them, the 12 voltage in the lower loop would be divided equally among them. And I say 12 volts because in parallel circuit, each loop gets the same voltage. So the upper circuit as well as the lower circuit would both get 12 volts. Again, P and Q have the same IV characteristics, which means 12 volts would be equally divided among them. So the potential difference across P would be 6 volt, and that across Q will also be 6 volts. Now we're supposed to find the current in lamp P. To do that, we can use the graph in figure 5.1. As you can see, 6 volts of potential difference corresponds to 1.55 amperes of current. This means the current through P and through Q is 1.55 amperes. The total power dissipated in lamps P and Q. So power is equal to potential difference multiplied by the current. Since P and Q are in series, they would have the same current, 1.55 amperes. And the total potential difference across them is 12 volts. So this is 12 multiplied by 1.55, and that is equal to 19 watts. Corrected to two significant figures. Part 3. Calculate the resistance of the potentiometer between its ends A and B. Through A and B, the potential difference would be 12 volts. We are also given that the battery produces a current of 1.78 ampere. We initially found that 1.55 amperes from this will flow into the lower branch, which means to find the current through A and B, you would subtract 1.55 from the total current, and so this gives the value 0.23 amperes. Remember, current according to Kirchhoff's law, the sum of currents moving into a junction would be equal to the sum of currents moving out of it. Total current which moves in, which is 1.78, which is why from you would subtract 1.55 amperes from it to find the current through A and B. Again, since A and B is connected in parallel with P and Q, the potential difference would be 12 volts. And so now you have the potential difference as well as the current. You can find out resistance. resistance would be potential difference divided by current, which would be 12 divided by 0.23, and that's 52 ohms. D. The slider of potentiometer in C is moved to end A. State and explain the effect on the brightness of lamps of P and Q. For this part, I would like to think of P and Q separately as potential dividers. I'll start with differentiating between potential difference and potential. So potential is like potential energy. For example, gravitational potential energy increases with an increase in height. So the higher up you go from the surface of Earth, the gravitational potential energy increases. Similarly, the closer you move to the positive terminal of the battery, the higher the potential would be at a particular point. So A in the potentiometer, being closer to the positive terminal, is at a higher potential. The potential of A would be higher than the potential of B. Now that was potential. Potential difference is the energy that's used across a component. So potential at A is 12 volts. Since none of the EMF from 12 volts has been used, there was no component between point A and the positive terminal of the battery, which is why at A the voltage, the potential is 12 volts. At B, the potential would be 0, and that's because across the potentiometer you would use up all of the energy. So the potential at B would be 0, potential at A would be 12. Now potential difference is the energy that has been used. Across AB, this would be 12 volts. When the slider is at A, the potential difference across P is the potential difference between A and this left hand side junction of the upper loop. And that's because, as you can see, lamp P is connected in parallel to this part of the circuit. So potential difference of P is equal to the potential difference across A and the junction, which I have circled. So between these 2 points of A and the junction on the left hand side, the potential difference is 0, because there isn't any electrical component between these 2 points that would use up electrical energy. So that means the potential difference across P is also 0. This is why lamp P would have no potential difference, and so the light will go out. In this diagram, we'll look at lamp Q when the slider is placed at A. So as I mentioned earlier, the potential at A would be 12 volts, and this would be used up across the potentiometer, which means the potential on the right hand side junction of the circuit would be 0 volt. Now Q is connected in parallel to these 2 points, to the point A and this junction, which means potential difference across Q is equal to the potential difference between A and the junction, and that is 12 volts, because the potential at A is 12 and it reduces to 0 at the end of the loop. So that is why Q will receive maximum voltage and its brightness would increase. Question 6a. A lepton is an example of a fundamental particle. State what's meant by fundamental particle. This is a particle that cannot be broken down into smaller particles. An example would be electron. B. A lambda particle is a hadron that consists of an up quark, a down quark, and a strange quark. Show that the charge on the lambda particle is 0. A hadron is essentially a subatomic particle that's made up of either 3 quarks or a quark and an antiquark. So in this case, we've got a baryon since we've got 3 quarks, up quark, down quark, and a strange quark. The charge of an up quark is plus 2/3. Down quark has a charge of -1/3, and similarly, strange quark has a charge of -1/3. When you add these together, you would have a charge of 0. The lambda particle is unstable. It can decay into a neutron and a pion as shown by the equation. The pion particle consists of an up quark and an up antiquark. One, compare the properties of up quark and an up antiquark. So quarks are fundamental particles, which means up quark and an up antiquark are both fundamental particles. However, they would have opposite signs of charge, whereas they would have the same magnitudes of charge. So up quark would be plus 2/3 and up antiquark would be negative 2/3. They would also have the same mass. To explain why the neutron is classified as a baryon and the pion particle is classified as a meson. Neutron consists of an up quark, a down, and two down quarks, so that is 3 fundamental particles, which makes it a baryon. And pion particle consists of a quark and an up antiquark, which is why it's a meson. This is it. We are done with this paper. Thank you for watching.